Hello again, grade 8s. In today's lesson, we're going to wrap up the unit of study on linear relations. And we're going to do that by probably doing debatably one of the most difficult tasks, which is going to be to try to write out what the equation of a linear relation would be based on either data from a table of values or from a graph. Now, we don't need to go through any additional notes. We're simply going to jump into a couple of examples. And in these examples, we'll eventually get to writing the linear equations, but a lot of it's going to be a review where we tie like all the different things we've talked about previously together. Okay, so the first example I have, it says, the following table illustrates the relationship between the amount of money a person is paid based on the number of magazine subscriptions sold. So your top value in the table, which would be your X values, are the number of magazine subscriptions, and the bottom value is going to be your pay in dollars. Okay, so A says describe the pattern that you can see in the table. Okay, so what I want to know is, and you can see here, that for every increase in 5 subscriptions sold, how much would my pay increase by? Okay, so I'll say for every 5 subscriptions sold, what happens to the pay? Well, you can see here, it goes up by increments of 20. So I go from $0 to $20. If I go from 5 subscriptions to 10, so you add another 5, then your pay increases by another $20. So for every 5 subscriptions sold, the person earns $20. Okay, now based on this, knowing that for every 5 additional subscriptions sold, we earn $20 more. Let's try to fill in these last 2 entries here. Okay, so if we go from 10 to 15, we add $20. If we go from 15, so if we add another 5 subscriptions sold, we'd add another $20 to this. So this would then go up to a value of 80. And if we go from 20 to 25, so again, another 5 subscriptions sold, we earn an additional $20. So 80 plus 20 would then be 100. Okay, so that's my completed table of values. C, I want to plot the data on a completely labeled grid. Okay, so let's start off by writing down our titles. So what's going on here? The person's selling magazines. So maybe an appropriate title would be magazine sales. And now let's write a title for the x-axis. Okay, so the x variable is the number of subscriptions. So write down number of subscriptions. Okay, so that's the name of the variable. Then we put a comma. Then the symbol used to represent that variable. If we go back to the data table, we're using n to represent it. Now, typically you put units in brackets, but there are no units here. Okay, we're just talking about like discrete amounts of subscriptions that are sold. So we're not going to write anything in brackets. Okay, now for the vertical axis, we're going to identify our pay. Okay, so I'm going to attempt to write this. So we've got the and this is much easier for you to do because you can just rotate your page. I cannot. Okay, so we got my pay. That's the name of the variable. Okay, the symbol used to represent pay is P. And this actually does have units. So my units here would be dollars. Okay, pay in dollars. Now we need to create an X scale and a Y scale. So let's go to an X scale. So x scale is take the biggest x value. So again, here are my x values, here are my y values. That's 25. Divide that by the number of squares on the grid. So that's going to be divided by 10. 25 divided by 10 would be 2.5. But we're not going to label every single grid line. We're going to go up by 2s. So we're going to double that number. So 2.5 multiplied by 2 would be 5. Therefore, we're going to go 0, 5, 10, 15, 20, and then 25. Okay, now my y scale, take the biggest y value, which is 100. And we're going to divide by the number of squares on the y-axis, which is 10. So 100 divided by 10 is 10. Again, so every grid line will go up by 10, but we don't want to label every grid line. We'll label every second one. So we're going to double this number. So that'd be 20. Therefore, we're going to go up by 20, 40, 60, 80, and then all the way up to 100. Okay, now we're going to plot the points in the grid. So we've got 0, 0, which would be at the origin here. We've got 5, 20, which would be at this location. We have 10, 40, which would be up there. We have 15, 60, which would be up there. We have 20, 80, which would be up here. And then we have 25, 100. Okay, now draw an appropriate line through the data. So we need to decide, are we going to draw a broken line, or are we going to draw a broken line or a solid line? Okay, now here's where it's a little bit tricky. So the question is, do in-between values make any sense? So let's say that we were between 5 and between 10. So an in-between value like 6 or 8 would make sense, because you could sell six subscriptions or 8 subscriptions. But the thing is, all in-between values would have to make sense. So all in-between values could, for example, be along this grid line. Now, this grid line would mean that you would have 7.5 subscriptions. And again, that makes no sense, because like you're not going to sell like have 1/2 of a magazine to a person. It's either you're going to give them a whole magazine or you're not going to do it. So let's clarify this here. So I'll say, although some in-between values are allowed, so the example I used is, yeah, you could sell 8 subscriptions. That's a number that falls between 5 and 10. But not all are allowed. So for example, you cannot have n is equal to 7.5. You're not going to say to the person you're trying to sell the magazine to, like, hey, can I rip the magazine in half and just give you like 1/2 of it? Like, no, like you're going to sell the whole thing. You're not going to do it. Okay, so because of this, it means that the data is discrete. And if the data is discrete, we're going to draw a broken line. Okay, so I'm going to grab a line here. You can do this with a ruler now very easily. And again, you should do this with a ruler. Okay, so let's grab a line here. Okay, let's change it so I can see it. Well, first of all, let's change it to blue in color because that stands out pretty nice. I'll make the thickness so I can see it. Okay, now this has to be broken, so I'm just going to change it so that it's dashed. Okay, so I got a dashed line here. And then let's try to get it so it goes through all these points. And that looks roughly pretty good. Okay, So back to that slide. Okay, E says write an equation that could be used to calculate the pay based on the number of subscriptions that are sold. Okay, so what it's asking us for is it wants us to write an equation we could use to calculate P, what the pay is. Now, the way we're going to do that is we're going to look at what the connection is between the number of subscriptions N and the pay. Now, what I want to look at here is what can I do to go from the number of subscriptions to the pay? So for example, how can I go from 5 to 20? How can you go from 10 to 40? How can you go from 15 to 60? How can you go from 20 to 80? How can you go from 25 to 100? So what's the commonality here? Like what operation, like what could I either take this number and add by, multiply by, subtract by, divide by, that would allow me to go from 5 to 20, 10 to 40, 15 to 60, 20 to 80, 25 to 100. Well, if you answer this correctly, it would be multiplication by 4. 5 times 4 is 20, 20 times 4 is 40, 15 times 4 is 60, 20 times 4 is 80, and 25 times 100 is going to be, 25 times 4 is going to be 100. Therefore, the way I'd write this out is if you could take 4 and you multiply by the number of subscriptions, this would be equal to the pay. Or we can write it the other way around. We can write it with the pay on the left-hand side of the equal sign. And in an actual mathematical equation or expression, we don't need to show that operator between the numerical coefficient and the variable. So we could actually just write down P is equal to 4 times N. Okay. So what this means here is if you take 4 and multiply by the number of subscriptions, that would be equal to the pay. Now, here's where the equations are useful. The equations are useful when you have really, really large numbers. Like, for example, it says, what's the pay if we sold 40 subscriptions? Well, we're not going to extend the table of values here because, I mean, I wouldn't have enough space to do it. You could extend it to like 30, 35, 40. I guess that actually would work out okay if you did that. If I said 400 subscriptions, though, that'd be a problem. The graph, we can't figure that out because 40 subscriptions would be off the graph, so that's not going to be useful. Therefore, the equation is the thing we want to use. Okay, so we're going to evaluate this equation if N is equal to 40. Okay, so let's plug it into the equation. So we have P is equal to 4 times N. Now, in the place of N, I'm going to replace it with 40. So this is going to be P is equal to 4, and then bracket to indicate multiplication of 40. And then 4 times 40 would be 160. And because we made a prediction using the equation outside of our data points, that is what we refer to as being an extrapolation. Okay, let's go to the second example. So we have a pattern of shapes involving squares, as shown in the diagram below, where F represents the figure number or the shape number, and then S represents the number of squares that we can see in that figure. Okay, so what we want to do to start off with is construct a table of values for the first 6 figures. Okay, so let's make a title. So we're going to say the figure number. That's the name of the variable. Put a comma. The symbol we're going to use to represent it is going to be F, and we don't have any units here. Okay, so let's underline this and extend it over. Okay, now the Y variable is going to be the number of squares. So we're going to say number of squares. Okay, the variable we're going to use for that is going to be S, and again, it has no units. It's just like whole numbers. Okay, so we're going to do figures. It says do the first 6 figures. So 1, 2, 3, 4, 5, 6. Now, I only see 3 figures here, but we're going to be able to identify a pattern to figure out what the other figures would be. Okay, so for figure 1, let's count the number of squares. So you'd have 1, 2, 3, 4 squares. So that's going to be a 4 here. For figure 2, you'd have 1, 2, 3, 4, 5, 6, 7 squares. And then for figure 3, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 squares. Okay, now let's figure out what's going on here. So to go from one figure to the next, you're just adding ones. When you go from one figure to the next, what number of squares are you increasing by? Well, to go from 4 to 7, you'd be adding 3. To go from 7 to 10, you'd be adding 3. Therefore, 10 plus 3 would be 13. So figure number 4 would have 13 squares. 13 plus 3 would be 16. And then 16 plus 3 would be 19. Okay, then it says describe the pattern that is displayed in the table. So what I could say here is for every increase in the figure number, the number of squares increases by 3. And that's how we were able to fill in that table of values. Okay, now we're going to plot the data on a completely labeled grid. So we can actually form ordered pairs here. So if this is my X and this is my Y, my ordered pairs would be 1, 4, you'd have 2, 7, you'd have 3, 10, you'd have 4, 13, you'd have 5, 16, and then you'd have 6, 19. Okay, but first things first, we've got to label this and scale this graph. Okay, so what's a good graph here? Well, we're looking at a pattern that involves squares. So I'll just say pattern of squares. And keep the title relevant to what we're actually doing in the problem. Okay, pattern of squares. Now, if we did the table of values correctly, we can actually just copy the title for the table of values onto the X and Y axis. So the X title is just going to be this right here. So it's going to be the figure number. That's the name of the variable, a comma. The symbol to represent it is an F. And then we have the number of squares, which, okay, I gotta try to write vertically here. Okay, number there's a huge space there. Number of squares. That's an A, not a Q. Come on. That looks awful. Okay, but again, you can rotate your page to do this much better. Okay, number of squares, and the symbol we use for that is S. Okay, now let's create a scale. So let's go to my X scale. So X scale, take the biggest X value. So the biggest X value is 6. Divide by the number of squares on the x-axis, which is 10. So that's going to be 0.6. And then we want to double that. 0.6 times 2 would be 1.2. Okay, here's the problem though. This is really not a nice number to be labeling your grid lines by. It's like an ugly decimal number. So what we can do is, if we actually do this process, and we start to get decimal numbers that are ugly, which is going to make it difficult to read off the graph, we're allowed to round up a little bit, okay? So what I'm going to do is I'm going to round up to a number that's going to be a bit easier to read off the graph. And typically what you want to do is you just want to round up to the nearest whole number. So if you're at 1.2 and you round up to the nearest whole number, that would be rounding up to 2. Therefore, we can label this as every second grid line would go up by 2. So you'd have 0, 2, 4, 6, 8, and 10. Okay, that's going to be much easier to plot the points compared to like going up by 1.2 every second grid line. How about the y scale? Okay, so the y scale will take the biggest y value, which is 19, divide by the number of squares in the y-axis, that's 10. So 1.9 divided by 10 would be, 19 divided by 10 is 1.9. And if you take 1.9 and double it to plot every second grid line, that's going to be 3.8. So once again, I don't want to label ugly decimal numbers on the grid. So what we're allowed to do is round up. Now you have to round up. If you end up rounding down, you can actually make it so you won't be able to plot one of your points on the graph. So do a little bit of rounding up to the nearest whole number. So I'm going to round up to 4 because that's going to be way easier to read off the grid. Okay, so we go every second grid line by 4. So we go 4, 8, 12, 16, and then we're all the way up to 20. All right, now we're ready to plot these points. So the first point is 1, 4. So 1 would be here, 4 is located here. Again, by doing this nice rounding, it makes these points like nice and easy to plot. Okay, the next point is 2, 7. So we go 2, and 7 would be at this position. Okay, then we have 3, 10. So 3 and 10 would be right here. And then we have 4 and 13. So 4 and 13 would be located right here. Then we have 5 and 16. So 5 and then 16 would be all the way up at the top here. And then we have 6 and 19. So 19 would be located up here. Okay, so now that's my points that are plotted. Now draw appropriate lines through the data. So to determine that, you have to identify, like, is this data discrete or is it continuous? So again, the question to ask here is, do in-between values make any sense? So once again, some in-between values make sense. If you have like 2 and 4, a number in between that would be 3. Figure number 3 makes sense, but all in-between values have to make sense. So would figure number 2.5 make sense? No, it's either you have figure number 2 or you have figure number 3. There's no middle ground there, okay? So we can say the data is discrete. So I'll say, for example, you cannot have f is equal to 4.5, for example. Again, I just question, like, can you have a decimal number? Does a decimal number make sense? And like, there are a lot of problems where it does, in which case the data would be continuous, but here it's discrete, which means we're going to draw a broken line. Okay, so I'm going to go copy that broken line from that other slide. So let's just end this for a moment. I want to keep my writing. We'll go over here, grab this line, copy it, come back to this picture. Okay, paste it here. And then let's try to get it so it hits all these points. This slope is a little bit steeper here. Okay, and I got to make it so it spans a graphing area but doesn't go past it. And that looks pretty good. Okay, so then if we look at the graph, it looks like this. Okay, now E says write an equation that can be used to calculate the number of squares, S, sorry, this should be a lowercase s here, based on the figure number. Okay, this is hard, okay? So this one wasn't bad because to get from like one variable to the other, all you had to do was multiply by 4, okay? No problem. Now, the issue with this one is you're not going to be able to do it in a single operation. So if I look at the graph here, I'm trying to figure out how do I go from 1 to 4, or how do I go from 2 to 7? So initially you might be thinking, okay, well, to go from 1 to 4, just multiply by 4. But then that has to be true for every single one of these points here. So 1 times 4 would be 4, but then 2 times 4 would be 8, so that's wrong, okay? And then if you kept going, 3 times 4 would be 12, so that's also going to be incorrect. In fact, more often than not, multiplying by 4 is going to result in a number that is just flat out way too big. Okay, so we're actually going to have to do 2 operations here. Okay, so the first operation I'm going to do is, and again, a lot of this is just trial and error. Like you just have to like ask yourself, how do you get from like F to S? What things do you have to multiply, divide, add, subtract by to do it? Okay, so I'll tell you that part of it is going to involve multiplying by 3. Okay, part of it is going to involve multiplying by 3. So 1 times 3 would be 3, so that's not 4. 2 times 3 would be 6. That's also not equal to 7. But there's something else I can add to this afterwards. Okay, 1 times 3 is 3, and I need to get that up to 4. 2 times 3 is 6, I need to get that up to 7. Or here, 3 times 3 would be equal to 9, but you need to add something else to get to the 10. So what's the common thing I need to add here? You have to add a 1, okay? And like I said, there's not really an easy way to like determine this, like aside from just like you need to just kind of play around through trial and error and figure out, okay, what do I need to multiply by, divide by, subtract by, etc., to get from like F to S. And sometimes you might have to do 2 operations, okay? And that's why this one's hard, because you actually do have to do 2 operations to deal with it. Don't worry, you would not have to do anything beyond 2 operations. Okay, so let's start to like summarize what we're doing here. So I'll say to get from F to S, we're going to multiply F by 3, and then we're going to add 1. Okay, so what would that look like? We're going to take 3, we're going to multiply by the figure number, we're going to add 1, and then that's going to be equal to S. And we can confirm this. So we go back here. 3 times the figure number 1 would be 3, plus 1 is 4. 3 times the figure number of 2 would be 6, plus 1 is 7. 3 times the figure number of 3 plus 1 would be 10. And you could actually confirm it through the other 3 points as well. Okay, now we can rewrite this. I'm just going to put S on the left-hand side, the equal sign. Now we don't have to show this multiplication operator. We can just write down 3F, okay? Because if 3F, the multiplication operator is implied, and then 3F plus 1. So my equation is S is equal to 3F plus 1. And then F says use the equation derived in E to determine the number of squares in figure 20. Okay, so expanding the data table is not an option here because you have to expand it to like 20 different rows. We have nowhere near enough space to do that. The graph only goes up to a figure number of 10 and a number of squares of 20, so that's not going to fit in the graph. So we're going to use the equation to do this. Okay, so I'm going to evaluate the equation if F is equal to 20. Okay, so my equation is S is equal to 3F plus 1. So this would be equal to 3. And in the place of F, we're going to replace it with figure number 20. So 3 times 20 plus 1. 3 times 20 is 60. So you'd have 60 plus 1 would be equal to 61. So in figure number 20, you would have 61 squares, okay? So like I said, this is the toughest thing to actually do. Not always. I mean, sometimes it's pretty easy to get from one variable to the other one, but sometimes it's a little bit more complicated where you just have to try to be patient and just try a bunch of different operations until it does work. Okay, so that's it for all of the content lecture-wise in this unit. And you can practice this lesson by completing the assignment called Writing Linear Equations. And then I'll talk to you in the next unit.